Assalamu alaikum. Welcome to lecture number 13 of Software Design and Architecture. I am your course instructor Fahad Anwar. So students, before I start my today's lecture discussion, I would like to give you a little bit recap about our last lecture. So students, what we discussed in our last lecture, if you remember, we see different contributory factors which are actually involving in the software architecture, where we see the five different factors like quality attributes, IT environment, human dynamics, business strategy and design, and we see how these five factors actually contribute in the software architecture. And then we see the role of software architect as a design expert, as a design domain expert, as a technology expert and the methodological expert. We see these different four types of role of any software architect. And then we see what are the quality attributes are actually involved in the good architectural design, where we see the efficiency, correctness, reliability, portability, maintainability. And then further we see the four different types of maintenance as well, where we see the corrective maintenance, adaptive maintenance, perfective maintenance and preventative maintenance. And then we see the cost of maintenance attribute as well, where we see maintenance is as high as 67% of the cost of entire SDLC. And then we see the reusability attribute and interoperability attribute of any good architectural design as well. So students, it's a little bit recap about our last lecture. So let's start our today's lecture number 13 discussion. So students, here is brief objective of our today's lecture discussion. We see in this lecture different quality attributes which are actually involved in the software architecture, and then these quality attributes in software architecture are actually grouped or divided into three different categories as well: implementation attributes, runtime attributes and the business attributes as well. And in the last we see how uh, the trade-off between different quality attributes are, we will also discuss, we can't achieve all the quality attributes in a single architecture. So there is some trade-off pairs between these quality attributes as well. So these are the brief objective of our today's lecture discussion. So students, let's start what quality attributes in software architecture. So students, you must remember every architecture has some pros and cons, and there are some potential risks involved as well. So the basic purpose is to to meet or satisfy the required functions and quality attributes of the user is very important. So basically these quality attributes are the non-functional requirements. So what are the quality? So you must remember, quality refers to any measurable characteristics like reliability, portability, usability, efficiency, performance. All of these are quality attributes which are measured at runtime or non-runtime as well. So further, these quality attributes are plays an important role in a software architecture. So quality attributes are not standing alone, so mainly those are tightly coupled with required functionality and other architectural constraint as well. So students, if I give you an example, so as an example, if there is a requirement like I say, when user clicks the load button, all customers should get loaded into the page. So the requirement should define how soon this data, in how much time the data loading should happen. So this requirement is tightly coupled with the performance quality attribute as well. So might be coupled with scaling as well. So if our system is going to be a distributed one, so you see that this requirement is actually mounted with the performance level attribute and the scaling level attribute as well. So we can say that within complex systems, quality attributes can never be achieved in isolation. So the achievement of any one will have an effect, sometimes positive effects and sometimes negative effects on the achievement of these quality attributes in any architecture. So quality attributes is now further divided into three broader groups. So what are these quality attribute groups? The first one is the implementation attributes. uh, students, implementation attributes is are not observable at runtime. So इम्प्लीमेंटेशन लेवल का जो एट्रीब्यूट है ये रन टाइम के ऊपर हम इसको ऑब्जर्व नहीं करते, इसको बेसिकली हम ऑब्जर्व करते हैं डेवलपमेंट टाइम के ऊपर या इम्प्लीमेंटेशन टाइम के ऊपर. सो वी कैन से दैट इन दिस we can say that in this implementation attributes, uh, uh, quality attributes that are describes the development of the system, like such as modifiability, testability. So we can say that in the implementation attributes we consider those quality attributes which are not observable at runtime. So in this implementation attributes it actually involves only those attributes which are describes at the development of the system. And the next one is runtime attribute. As the name suggests, the runtime attributes are those attributes which are actually observable at runtime. So students, what are the runtime attributes? Like जिसको हम system को run करने के बाद ही उसकी quality को assess कर सकें, like the availability of the system, usability of the system, performance of the system, efficiency of the system. All of these kinds of quality attributes are considered at runtime attributes, because these runtime attributes are only observable at runtime. And the last one is business attributes. So business attributes are most oriented toward the business strategies like time to market, cost, lifetime. These will be discussed in later stage. So till here our quality attributes are basically grouped into three broader categories: implementation attributes, which I called not observable at runtime, and second is the runtime attribute, which I called observable at runtime, and the last one is business attributes, where we see the time to market, cost, and lifetime of different attributes as well. So these are the three broader categories of quality attributes. So we will discuss each quality attributes one by one in more detail. So let's start with the implementation attributes. So students, implementation attributes are not observable at runtime. So these quality attributes are usually described as the development time of the system. Like these are the different attributes which are actually we see or check at the implementation level or at the development level, not at the runtime level. So these are the different implementation level quality attributes which we must address in our software architecture, ranging from interoperability to flexibility. So let's students, we discuss each individual these implementation level attributes one by one. Like interoperability is basically, we can say that is you can say that it's universal accessibility and the ability to exchange data among internal components and with the outside world. So we can also say that interoperability requires loose dependency of infrastructure. So if I tells you in more easier word, interoperability is an attribute of the system or part of the system that is actually responsible for its operation and transmission of data and its exchange with external system. So like we also can say that a well designed system also facilitates us with the integration with third party systems as well. So to improve the interoperability you can use like well designed external interfaces, standardized system, etc. And the next one is maintainability and extensibility. As the name suggests, maintainability is actually about the changing about the system, like its ability of the system to support different level of changes as well. We also see four different types of maintenance in our last lecture as well. And the extensibility. So modify maintainability and extensibility is actually about the ability to modify system and how much it is convenient for us to extend our system. So extensibility is about to conveniently extending the system, and maintainability is about how well our architecture can help us to modify the system. And we also see for different types of maintenance in our last lecture as well. And now the next one is testability. So testability is, we can say, is the degree to which the system facilitates the establishment of different test cases. Now students, what are the test cases? You will also study these different test cases in your quality assurance subject as well. So I will not put more focus in this test cases or testability. You generally can understand this term. Testability usually requires a complete set of documented accompanied by system design and implementations as well. And next one is the portability. As the name suggests, portability is actually about the independence on software and hardware platforms. Like portability, we can also say that portability is actually about how much easier for us to utilize our system from one environment to another environment. So if I give you more details about portability, you we also discussed this term portability in our last lecture. So students, if you remember about the portability, so portability is actually about how much it is easier for us to utilize our system from one environment to another environment, or in, if I say more in short form, we can say that actually portability is let's took if we took some example as well, like system develop most of the systems developed using high level programming languages usually have good portability. So one typical example is Java. So most Java programs need only be one compiled once and can run everywhere. So it's the example of portability as well. And now the next one is scalability. So as the name suggests, scalability is actually about our architecture must be scalable enough so that the system can be easy to adopt, to increase in user requests as well. So basically scalability is about our architecture is how much provides the easiness to enhance the system as well. And now the next one is the flexibility. So flexibility is about the ease of system modifications to different environments. फ्लेक्सिबिलिटी है कि हम हमारा सिस्टम हमें कितना इजीली मॉडिफिकेशंस डिफरेंट इन्वायरमेंट्स के अंदर प्रोवाइड करता है फॉर विच द सिस्टम वाज नॉट ओरिजिनली डिजाइंड एज वेल. सो वी कैन से दैट सिस्टम डेवलप्ड यूजिंग कंपोनेंट बेस्ड आर्किटेक्चर और सर्वर्स ओरिएंटेड आर्किटेक्चर यूजुअली पोजेसेस दिस एट्रीब्यूट. जो हमारे पास सर्विस ओरिएंटेड आर्किटेक्चर के सिस्टम्स होते हैं या कंपोनेंट बेस्ड आर्किटेक्चर हैं, यूजुअली वो फ्लेक्सिबिलिटी के एट्रीब्यूट्स को पोजेस करते हैं. And students, these are the detailed discussion about these implementation attributes which we call a not observable at runtime. And almost many of these attributes we also discussed in our previous lecture as well. So that's why I'm not going into more deeper details as well, because we also see these different kinds of quality attributes in our last lecture as well. But in this lecture we actually divide these quality attributes into three different groups: implementation attributes, runtime, which we call the not observable and runtime, and the second is the runtime attribute, and the last one is business attribute. So our theme of this lecture is to see these different quality attributes into three broader groups as well. And now our next attribute is the runtime attribute. So students, the most easiest attributes are here for your understanding, which are basically observable at runtime. रन टाइम एट्रीब्यूट्स ऐसे एट्रीब्यूट्स होते हैं जिसको हम अपने सॉफ्टवेयर के रन टाइम के ऊपर अपने आर्किटेक्चर की डिफरेंट क्वालिटीज़ को असेस करते हैं. सो क्वालिटी एट्रीब्यूट्स दैट आर डिस्क्राइब सिस्टम्स एट रन टाइम प्रॉपर्टी. सो दीज आर द डिफरेंट क्वालिटी एट्रीब्यूट्स विच आर ऑब्जर्वेबल एट रन टाइम: अवेलेबिलिटी, सिक्योरिटी, परफॉर्मेंस, यूजिबिलिटी, रिलायबिलिटी एंड maintainability as well. So students, availability is pretty straightforward, like is the ability of the system to be available. Like we also utilize this most common term 24/7, like our system should be available 24 hours a day or a 7 days in a week. uh, Availability can be achieved by replication and careful design to cope with failures of hardware, software, or the network. And the next one is security, is also straightforward. Is basically security is about the ability of the system to cope with the malicious attacks from outside or inside the system as well. Like security can be improved by installing different kind of firewalls, like establishing different kind of user authentication, like different kind of passwords or encryption tools as well. And the next one is performance. So students, performance, what is performance, is actually about the efficiency of a system, like increasing a system efficiency with regard to response time. So efficiency and performance are two similar kinds of quality attributes as well. And the next one is usability. Usability is about how much our software architecture or software is easier to use for our end user. Like usability is involve the level of human satisfaction from using the system. How much actually human is satisfied from using our system. Like we can say that usability include matters of completeness, correctness, compatibility, as well as friendly user interfaces. All of these comes under the attribute usability. And the next one is reliability. So actually if you put focus on your mind, reliability is actually about the ability of the system to behave as it is specified. Like we can say the failure frequency, the accuracy of output results. Reliability can be measured by using different metrics like mean time to failure, etc. And the last one is maintainability. This maintainability we also see in the implementation attribute as well. So maintainability is also important in observe at runtime attribute level. So maintainability is about the ease of the system can be changed. Sometimes maintainability is similar to extensibility, adaptability, serviceability, testability, compatibility. All of these different kinds of system changing behavior attributes are actually more prone towards the maintainability. So students, all of these approximately six levels of quality attributes which are observable at runtime are well understood. Most of you are well aware about this runtime attributes as well. So there are a lot of examples available as well. You can also go through from on your own behalf as well. So basically these are the different runtime attributes which are observed at the runtime in any software architecture. And now the next one is business attribute. Now business attribute are the third group of quality attributes in any software architecture. So first one is time to market, which means the how much time it takes from requirement analysis to the date a product is actually released. It is we can say that time to market is actually about how much time it takes from requirement analysis to the date a product is actually released. And next one is the cost, pretty straightforward. It actually depicts the expense of building, maintaining, and operating the system. And the last one is lifetime of our product, like the how much the period of time that a product is alive before retirement. So it's all about the three aspects of business attributes: time to market, cost, and lifetime. And now students, let's discuss different trade-off between quality at different quality attributes. So in many cases we can say that no single architecture can meet all quality attributes. हम तमाम क्वालिटी एट्रीब्यूट्स किसी सिंगल आर्किटेक्चर के अंदर अचीव नहीं कर सकते. समटाइम्स हम किसी एक क्वालिटी एट्रीब्यूट को अचीव करने की तरफ जाएं तो हमारा दूसरा क्वालिटी एट्रीब्यूट कंप्रोमाइज़ हो जाता है. सो software architect often need to balance trade-off among these attributes. Like typical quality attributes, trade-off pairs are space and time, reliability and performance, scalability and performance. So let's discuss these pairs of different trade-offs in more detail. So first one is trade-off between space and time. Let's take the example about space and time. For example, we say to increase the time efficiency of a hash table means a decrease in space efficiency. आप time efficiency को hash table में इंक्रीज़ करने की तरफ जाते हैं तो आपकी जो स्पेस एफिशिएंसी है वो डिक्रीज़ हो जाती है. आप स्पेस अचीव करने की तरफ जाते हैं, टाइम क्वालिटी एट्रीब्यूट कंप्रोमाइज़ हो रहा है. अगर टाइम को एट्रीब्यूट को अचीव करने की तरफ जाएं तो स्पेस एट्रीब्यूट कंप्रोमाइज़ हो रहा है. सो दिस इज़ द ट्रेड ऑफ बिटवीन स्पेस एंड टाइम. एंड द नेक्स्ट वन इज़ ट्रेड ऑफ बिटवीन रिलायबिलिटी एंड परफॉर्मेंस. Let's take another example. For instance, Java programs are well protected against buffer overflow due to security measures such as boundary checks on arrays as well. So such reliability features some come at the cost of time efficiency, like compared with simpler, faster C languages, which provides a dangerous efficient pointers as well. So there is also a trade-off between reliability and performance as well. And the last one is trade-off between scalability and performance. Let's take another example for this trade-off of scalability and performance. For example, I say one typical approach to increase the scalability of a service is to replicate servers. So to ensure consistency of all servers, performance of the whole service is compromised. So हमने क्या देखा कि हम अगर अपनी स्केलेबिलिटी को अचीव करने की तरफ जाएं, जो हमारे सर्वर की डिफरेंट सर्विसेज को रेप्लिकेट करे, तो हमें अपने सभी जो सर्वर्स हैं उनकी कंसिस्टेंसी को अश्योर करने की तरफ जाएं। तो हो सकता है कि जो हमारी परफॉर्मेंस है होल सर्विस की जो हम प्रोवाइड कर रहे हैं वो कंप्रोमाइज़ हो जाए। सो इन दिस स्लाइड वी सी, अगर हम स्केलेबिलिटी को अचीव करने की तरफ जाएं तो हमारी परफॉर्मेंस कंप्रोमाइज्ड हो रही है, और अगर हम परफॉर्मेंस को अचीव करने की तरफ जाएं तो हमारी स्केलेबिलिटी compromise हो रही है. So these are the three different quality attribute trade-off pairs where we see if we are going to achieve one quality attribute, the other one is compromised, and if we are going to achieve a second quality attribute, our previous one quality attribute is also compromised. So in any single architecture, no single architecture can meet all quality attributes simultaneously. So that's why these are the different trade-offs between these quality trade-off pairs. So students, we can conclude our talk here is that we can't say that a single architecture can satisfy about all the quality attributes. As we see, there are different trade-off exist between these quality attributes as well. So here, it is the responsibility of software architect to closely work with the system analyst and stakeholder as well, to more deeper or nail down the priority of quality attributes, whatever the quality attributes are important for the stakeholders. So first, you should go towards those more important quality attributes, and by enumerating different alternative architectural designs and calculating different weighted evaluation of among different attributes, so software architect can select more and more optimal design as well. So we can say that when an architecture does not satisfy all desired quality attribute, software architect more conscious toward the stakeholders requirements, or it most conscious toward the most high priority quality attributes. So and it's also put more its focus on these more customer oriented quality attributes. So till here students, our lecture number 13 is ended.